Question 14. Two parallel plate capacitors A and B are identical in area. So the area for both capacitor is the same. So I can write it here. The area for A equal to the area of B because the keywords identical in area. Okay, then the question tells us that A is filled with a dielectric constant epsilon R 6.7 while B is empty. So for capacitor A, it is filled with a dielectric constant in between the gap of the plates, whereby the dielectric constant is given as 6.7. For B is empty. Empty means is a filled capacitor. Means tengah-tengah ni empty. So capacitor B is a filled capacitors. Capacitor A we have dielectrics. So both capacitors are connected to same potential difference. So we highlight it. Same potential difference means the voltage across the capacitor is the same. So the voltage for capacitor A and voltage across capacitor B is the same, and store same amount of charge. So they store same amount of charge. It means that the charge stored in capacitor A equal to the charge stored in capacitor B. So what would be the separation distance of parallel plates A in terms of separation distance of parallel plates B? So I assume the separation between the two plates for capacitor A is dA. The separation between two plates for capacitor B is dB. So the question asks us to find the dA, or we need to determine dA, the separation distance of parallel plates A, in terms of separation distance of parallel plates B. Means we need to put it in terms of plates. Separation in plates capacitor B. Okay, so kita nak dapatkan lah whether the separations for parallel plates A is 2 times of separation distance of parallel plate B, or only half of it, or 4 times. We want to get the relations. We need to put it. dA is how much of dB. Okay, so where we want to start with? Macam mana nak mula selesaikan soalan ni? So we always start with the informations given. So since the question says the capacitors store same amount of charges, so maybe I can start with this statement. So we know that for both capacitor they are storing the same amount of charge. It means that QA is equal to QB. Okay, then we might relate the Q with the voltage and also the value of capacitance of the capacitors. So we have Q equal to CV. So Q for capacitor A will be the capacitance of capacitor A multiplied with the voltage across capacitor A. So QB will be the capacitance B multiplied with the voltage across the capacitor B. So since the question say they are both connected to the same potential difference, so means that this value can be cancelled because the value is the same potential difference. So we have CA equal to CB. So if we refer to the list of formula, or if you recall the concept we learned in LO2.3, we know that for A filled capacitors, we have the capacitance is epsilon naught A over D. But when we insert dielectric, when the parallel plate capacitor is inserted with dielectrics, then the capacitance will increase, whereby the capacitance will be the dielectric constant multiplied with the value of the A filled capacitors. So it will be epsilon naught epsilon R A over D. So we apply the equations. So capacitor A we have dielectric, so we have epsilon naught epsilon R A over D. So this one is for capacitor A, so I put it with subscript A. Capacitance for capacitor B will be a filled capacitor. So formula for A filled capacitor is epsilon naught area over the separation, but this one is for capacitor B. Okay, so the epsilon naught is the permittivity constant, so it can be cancelled. Then the question tells us that these two capacitors have identical area. Identical area means so the area can be cancelled out because the area is the same. So now we are left with the dielectric constant and the separation, so we can solve the questions. So the dielectric constant for capacitor A is 6.7 divided by the separation between the plate for capacitor A equal to 1 over separation between the capacitor B. So simplify it. So we will get the separation distance for capacitor A will be 6.7 times of separation between the capacitor plates in capacitor B. So this one will be our answer.